Hi everyone, welcome back to the third lecture of Python. Today we'll be continuing with the non-primitive data types which we have listed before. So as of now you guys have seen that we have completed the primitive ones. Okay, so what are non-primitive data types and how we are going to go towards? Let's first list down what all non-primitive data types do we have. Okay, so the non-primitive data types are the data types which are non-homogeneous in nature and it have one variable and multiple value, or let's say collection of values. Okay, so let's say what all falls under the category of non-primitive. First is your list, second is your tuple, third is your set, and fourth one is your dictionary. What we can do is we are going towards each of the data type one by one, and then we will understand its properties, what all built-in functions we can use in these data types, and then we are going to move forward into the next one. So the first and very important is the list, and list is something which is going to get very used very frequently when you work with Python. Okay, so let's start with list. Let's jump into the Jupyter notebook. Okay, so we have completed till the primitive data type, right? Now we will start with the non-primitive data type. Let me give you the heading: non-primitive data types. Okay, so we need to pay much attention to this data type, because as I told you that these data type is one value, or let's say one identifier multiple collection. Okay, so the first one we are talking about is list. Okay, so what is the definition of list? Anything which we are declaring inside the square brackets. Okay, if you guys can see, this is what square brackets look like. When we are declaring the identifier, we are assigning value to that identifier, and the value is nothing but declared inside the square brackets, then we are going to call them as list. Okay, for example, suppose I am giving one identifier name. Again, I'm repeating this. You can declare whatever identifier name you want. There is no limitation for that. List underscore 1 is my identifier name, and within this list I am opening and closing one square brackets. Now I'm going to declare elements inside it. Okay, now the question arises, what all data types I can declare inside this square brackets? What all data types I can declare inside this square bracket? Okay, so list accept every type of data. When I'm saying that, which means it could be either primitive in nature, it could be non-primitive in nature. You can declare all the primitive data types inside the square bracket. You can also declare all type of non-primitive data types inside the square brackets, but here the elements are used to be separated with commas. For example, this is my integer, so putting one comma, separating it with comma, putting one float data point here. If you want, you can give a string data type here as well. You want, you can declare bool as well. Now if you remember how bool looks like, there should be capital T, and it is going to turn into dark bold green. Okay, so this is one more data type. If you want, you can declare none as well, and if you want, you can declare list inside list as well. That I am not doing. There is one more question, that how many elements I can declare inside the list, right? How many elements I can declare inside the list? So there is the answer to this question is that we don't have any limitation. Okay, you can declare n number of values inside the list separated with commas. Okay, now you can see this is your list underscore 1. We have this many number of values inside this list separated with commas. Okay, now if you want to print this list, you can simply write print built-in function and write list underscore 1. This is how your list is going to look like. Now quickly check the data type. As you guys remember, previously for all the data types, we have checked the data type with the built-in function type, right? So I am going to use that built-in function type here and going to write down the variable name inside it. Since I'm going to run it, you will see it is going to show me the data type here as list. Okay, now since we know how to declare list, how to write, or let's say how to check the data type of the list, let me show you one interesting thing related to the list. Let's declare one list of all the numbers. I am declaring list of numbers like this, separating it with commas. And there is one website called as Visual Tutor. Okay, I'll drop the link for you guys. You can also go through this website and check how the data type actually looks like in the backend or in the memory. Okay, when I'm saying this, which means what I'm talking about. Suppose I'm copying this list. Okay, let's go to the Visual Tutor. Here I am pasting the list down. Okay, now it is going to visualize the code for you, which means how list actually works. It is going to show you that. So if I'm going to click on the visualize execution and click on next, you will see that there is one frame called as global frame. There are set of objects and we have values present inside this object. Okay, you can see this is my list. What all values I have declared inside this list, you can see those values properly here with no issues. Now one thing we need to put focus on, that something is listed down here above the objects 0 1 2 3 4 5 6, right? What are these things? When we are learning list, when we store elements inside the list, what are these things? When we write something inside the Jupyter notebook, you will see it is not going to get up here. If you look that in this Jupyter notebook, even if I'm declaring the list of numbers 0 1 2 3 something like that is not getting appeared here, but since I'm visualizing the code, it is properly visible here. So what is the meaning of these numbers which has been assigned to the every element of the list present here? Okay, in other terms we call these numbers as indexes. Okay, or we say that these are indexing or index of the list. Okay, let me copy this. Let's jump into the whiteboard. Let me show you what actually it is going to look like. Okay, wait a minute. Sorry for that. Okay, let's take a screenshot and let's upload the screenshot. That is going to be the easy way, so that I can explain you, right? Screenshots. Photos. Shared albums. All albums. God, I don't know why I'm unable to find that. Okay, leave it. Let's not waste time. Let me declare the list for you guys here so that it's going to help you. Okay, leave it. I'm going to declare list for you. We will declare the list as it is 10, 20, 30, 40. Okay, now if you guys have seen, there are some sort of numbering happened here in the elements of the list like this. Okay, so since these numbers are appearing, what are these numbers and what is the resemblance of these numbers? What I told you, these numbers are nothing but indexes. Okay, we call these numbers our indexes. And what do you mean or understand from indexes? Indexes helps us to identify the values present inside the list. You can see when we heard the definition of the list, it says that collection of different types of elements inside the square bracket, right? You guys have also heard that this square bracket can contain any type of data, right? So since this is the list of numbers and we are having the elements present inside it, what if I want to extract this 30 out of the list and use it separately? So in that case, I cannot do that because it is collection of element and I cannot break that collection. So in that case, it gives me the chance to draw the indexes out of this list and help me to extract that value with the help of this index position. If you are going to simply write the list of number, which is the name of your list, put the square bracket and mention the index position inside it, it is going to give you the value present inside that index position. And the process is called as indexing. So whenever we are extracting the elements out of the list with the help of its index position, by writing the Python programming statement like this, we call that procedure as indexing. Indexing helps you to extract the element with the help of its index position. Now let's jump into the Jupyter notebook and see how we can perform indexing in the real time. Okay, this is your notebook. Always understand that your indexing starts from 0. Okay, if you look into the Visual Tutor, you will see that once we are starting the indexing from here, it is starting from 0. This is 0, 1, 2, 3, and it is increasing in the +1 manner till we go by the end of the list. Okay, so this is the index position. Now based on this index position, we are going to write some Python program to extract the particular element out of this list. Okay, so I'm simply writing print because print is a built-in function which is going to help us to extract the element out of the list of number. Within the square bracket, I am mentioning 1. So this is the 0th index position, this is the 1 index position. So according to this, 203 is going to get extracted. You can see. Do not misinterpret, this is the square bracket for the list and this is the square bracket for the indexes. Okay, the type of brackets are going to get changed every time you are going to change the data type. You guys know we do have different non-primitive data types. Let's say as of now we are learning list. In near future we have tuple, sets and dictionary. Okay, so every time we are changing the data type, the nature of the bracket is also going to get changed. Okay, also coming to this point, whenever you want to perform indexing, because indexing is something which is supported not only with the list but with rest of the data types as well. Okay, so always remember indexing is going to get written in this format only. Okay, since let's say if you want to extract this 60, how you can do that? Because as you can see, the index numbers are not getting appeared here, right? So you have to count this manually. You know that indexes starts from 0. So this is 0, 1, 2, 3 and 4. So if you want to extract 60 out of the list of numbers, you're going to simply write list of number and then 4. It is going to extract 60 for you. Okay, now suppose if I give you one list which is very huge in nature. Let's say list large, and I am declaring some random set of numbers inside it just to make this list huge or large. And as you guys know, we can declare whatever type of data if we want to. Okay, now as you can see, it is very large list. What if I want to identify the index position of 9? What if I want to identify the index position, or what if I want to print XYZ out of this list? How we are going to do that? In that case, you have to manually calculate, right? From starting from 0, 1, 2, 3, we have to go till the end of the list to extract the element, right? That will become very difficult for us. So when we are in the starting position it is easy for us to identify the index positions, right? But what if my list is very huge in nature and I want to extract some elements from the last, second last, third last element of this list large? I cannot be sitting manually and counting the number of indexes to extract the values out of it. So in that case we have to understand that indexes are of two types. Okay, suppose this is your list and this list is very huge. Okay, this list is carrying n number of elements. Now if you are doing programming, you don't have enough time to count the index positions and you extract the element according to their index position. So in that case what you're going to do, as I told you, indexes are of two types. First one is the forward one, which you guys have seen, which started from 0, increase in the +1 manner, go till the end of the list. This is forward indexing. Okay, now the second type of indexing is the backward indexing. Now since I'm saying something is backward indexing, which means this is going to be started from the end of the list and your forward indexing moves in this direction, whereas your backward indexing moves in this direction. Okay, backward indexing always starts with -1. Okay, this is -1, -2, -3, -4, -5, -6, and it will go till the end, or let's say starting of the list. Okay, so forward indexing is useful when we want to access it from the front section. Okay, and backward indexing works when we want to access the elements from the backward section or from the last section. Okay, now since if I give you the chance to extract XYZ from this list of large, what you're going to do, you will take the help of backward indexing. So since I want to extract XYZ from the list, can I simply write list of large -1? Because instead of reading in the forward direction and going from 0, 1, 2 till the end of the list, instead of putting that much effort, why not to read from the back end and simply write -1 XYZ? Now you'll be asking me the question, but that is not appearing in the Visual Tutor. If it is a thing that something called as backward indexing exists, why it is not appearing in the Visual Tutor? So let me tell you, this is the funda which we initiated to extract the elements which are present in the bottom or in the last of the list. How we can extract those elements, right? It is not there available inside the Python by default. This is something which we created. Okay, Python only show you that something is there present in the forward indexing manner, but if something you want to extract in the backward indexing manner, it is not even there in the memory, because we don't have that much of time and space that we are going to access the same memory in the backward and forward direction in the Python. Okay, so this is the kind of a trick I'm telling you for us to extract the data out of the list. So this is the funda or concept called as indexing. Whenever we are having a list which contains the collection of element, and it's not possible for us every time to work with this collection of element, right? Sometimes we want one element out of the list, sometimes we want two element out of the list. So in that case, indexing is the thing which is going to help us to perform such activity. Okay, now we understood list, we understand what all data types we can declare inside list. We have also seen what is the concept of indexing. Now the third thing is called as nested list. Okay, now this nested term you are going to hear very frequently in the Python. What is nested? When I'm saying something is nested in nature, which means I am declaring similar data type inside the similar data type, which means suppose let's say I am declaring list inside list. Okay, I am declaring tuple inside tuple, I am declaring set inside set. So whenever similar data type gets declared inside the similar data type, we call them as nested in nature. Similarly, you can take the example of the nest. the nest which bird creates. Okay, with every let's say strand of a grass, arranging them in a proper manner, bird creates nest, right? Strand by strand of a grass, similar strands of a grass, you can see. The same thing is happening here. Similar data type inside similar data type, we are going to call that as nested list. How this nested list look like? Let me write nest of list. Inside that square bracket, 10 comma 20 comma 30 comma 40 comma 50. Now let's say I'm declaring one more list inside this which contains some sort of fruits in it. Okay, 89. Now let me pick this list up because it is a nested list, and we will understand this nested list in the visual tutor. Okay, I'm editing this, pasting my list down here, okay, and visualizing it. Now you will see how the proper visualization of this list looks like. We have starting, in the starting we have some sort of numbers, no problem. My list is looking perfectly fine. 10, 20, 30, 40, 50. Now in the fifth index position, you will see I declared one more list, right? So understand this thing that whenever you declare the nested list, okay, let me show you by declaring it here, list of nest. Okay, we are declaring list like this, 10 comma 20 comma 30. Again one list here, let's say apple, banana and XYZ. Okay, now these are the things. I have created one nested list. You need to understand that how indexing is going to happen in this nested list. This is going to be your 0th index position, 1, 2. I told you elements inside the list are separated with commas, right? So this whole list is going to be my 3rd index position. Okay, and this is going to be your 4th index position. Now you need to understand this is a list again, right? And list follows indexing. So within itself, within 3rd index position, if we are having a list, we can declare the index position inside it. Let's say 0 and 1. Okay, so suppose if you want to extract apple out of this nested list, you can simply write list of nest. How to reach to this position? With the 3rd index position. I am writing the 3rd index position. I want to extract apple because 3rd index position is list itself. So we have to again follow indexing inside the element of the list, which is going to be 0, 1. I want to extract this apple again. So I'm going to put one more bracket for writing the index and write the 0. That will extract apple for me. So the number of list present inside the list, that many number of independent brackets you have to give. Right now I have 2 brackets, or let's say 2 lists, that's why I'm giving 2 brackets. If I am having 3 lists, nested list within each other, I have to give 3 nested brackets. Okay, so this is how it works. So going back to the Jupyter notebook, let's see how in runtime this is going to appear. Suppose if I ask you to extract banana, okay, so first you have to reach in that position. If I give you the logic, you can reach this in the forward indexing way or manner. You can reach this in the backward indexing manner as well. Understand that this particular element is easily accessible with the help of backward indexing. This you can do with the help of forward indexing as well, but it is going to take a lot of your manual effort. Since we are moving here, we have to count 0, 1, 2, too much effort, right? Let's pick this in the backward indexing manner. Can I simply write list of nest with backward indexing? This is your -1. This whole list is going to be your -2, right? So first let's reach out to the -2 index position. Since I'm reaching out to this -2 index position, this is helping me to extract this list out. Now I have list in my hand. What is the next thing? I want to extract banana out of it. Either you can move in the negative direction or backward indexing, or you can move in the forward indexing. You can create the combo of both backward and forward. There is no limitation that you have to choose only forward and only backward. No, you can create combination. So since forward one starts with 0, 0 and 1, banana will get the index position 1. So this is -2 to reach out to this whole list, and this is 1 to reach out to the banana, and I'm printing it. You can see it will help us to extract banana. Okay, now this is the homework for you. Try to extract guava from nest of list. Okay, in next lecture I will be discussing the answer of this. Okay, let me mark this down as your homework. Whenever I start the next lecture, we will be discussing the answer of this. Okay, so this is completely the task for you. Do this and identify the index position of the guava. Okay, now you can see we are performing indexing within the simple list. We are also performing indexing within the nested list as well. Okay, now since the indexing part is over, I am requesting you to please be familiar with the indexing because it is very important part of the list. Now jumping into the next part, there is one built-in function. If you guys remember, what all built-in function we have covered till now? Let me clear this. We have covered 2 or 3 built-in functions, right? Built-in function. Let me give you the revision. Anything which is ending with open or close parenthesis, we are going to call this as function, built-in function, right? What is the first built-in function which we covered? Print. That helps us to print the output. What is the second built-in function we covered? Type, right? Now there is third built-in function called as help. Okay, these are the very basic built-in functions getting used with every data type. Okay, now print was helping us to print the output, type was helping us to judge the data type. Now help is going to help us, it will give us the guide related to that particular data type. Okay, so suppose if I'm going to write help and write list inside the help, it will give me the guide on the list. What all is there inside the list? What all definitions do we have? Okay, so if I scroll it down, you will see that there is one line written, methods defined here. Okay, we have understood what are built-in functions, but we don't have any idea what methods are. So let's understand. Your built-in functions are going to look like this. Your methods are something which always starts with dot, will carry some name, and end with open and close parenthesis. How to judge built-in functions? Like this. How to judge methods? Whenever you see something getting started with a dot, ending with open and close parenthesis, is called as method. Okay, now methods. Methods are nothing but completely dedicated for the data type, which means if I have list, and you can see in the help section of list we are going to have so many methods. We will see every method one by one and what are its usage. We can use those methods only with the list. You cannot use those methods anywhere else. Okay, so it is not possible. Whereas built-in function, you guys must be watching that I am using built-in function print with every data type, right? I am using built-in function type with every data type. There is no limitation for the built-in function. You can use built-in function with any data type, but methods are completely dedicated for that particular data type. For example, in our case, when we declare this help section of the Python, you will see we are having a lot of methods, and these methods you can only use with list. You cannot use it with any other data type. Okay. Since we are talking about methods, what all methods are there? First, I am suggesting you to ignore the method starting with a double underscore. What all methods are there starting with a double underscore? Ignore them all. Okay. Let's scroll it down, scroll it down, scroll it down. You will see methods which are getting appeared without any underscores, right? Those are the methods useful for us. Okay, those are the methods useful for us, and we are going to look into those methods, how to work with them. Okay, now we do have a definition written for every method, and we can see the definition of every method right in front, right beneath it. Okay, suppose first let me write down what all we have covered for list yet. Okay, so what is the definition of list? It is built-in data type. When I'm saying built-in data type, which means it is already there in Python and follows indexing. Okay, indexing works in both forward and backward direction. Forward indexing always starts with 0, whereas backward indexing always starts with -1. Okay, you have to keep this in mind related to the list. Now, once we discuss the indexing part for the list, let's talk about the methods for the list. Okay, methods for the list. So the first method you guys have seen in the help section is append, right? What is the purpose of the append? What if I want to add one element by the end of the list? What if I want to add one element by the end of the list? One element, okay? That too by the end of the list. If list is already declared, which means suppose you are having a list here, right? We have created list of numbers, okay, or list underscore 1. This is already created list. I want to add one element by the end of this list. I want to add, let's say, apple here by the end of the list. Understand that append add one element at a time, okay, that too by the end of the list. So I'm going to simply write list underscore 1. What is the identification of method? That you have to put dot, okay, append. Inside that you have to mention the element which you want to add. Okay, we want to add apple, that too by default it is going to get added by the end of the list. Okay, now if you print list underscore 1, you will see now it is getting modified and apple is getting added by the end of the year. Okay, now there is one more thing to understand, that methods make changes which are permanent in nature. We cannot reverse it. Whereas functions, whenever we apply function, it gives us some sort of output, but method we apply to manipulate the data type. Okay, and whatever changes you make with the help of methods, they are going to be permanent in nature, which means those are irreversible. Okay, so whenever you want to add one element by the end of the list, you are going to take the help of append. Okay, so keeping it that much for today. From the next lecture we will be seeing how to add multiple elements, where to add elements if we have index position according to our desire, how to delete elements from the list. All of these things we'll see one by one in the upcoming lecture. Thank you.